All right, today we're going to be looking at 5.2. It's the addition rule and complements. One of the first definitions we're given is two events are disjoint if they have no outcomes in common. So another name for disjoint is mutually exclusive. So if you see disjoint or mutually exclusive, it just means you have two events or two outcomes that don't have anything in common. So you can see from this figure, S is the sample space, and it is referring to the numbers, looks like 0 through 9, and E would be the event 0, 1, 2, and it does not overlap, has no numbers in common with what F has, which is 8 and 9. So these are what they refer to as disjoint or mutually exclusive. So then we come down here and we see the addition rule for disjoint. So if you got two events that have nothing in common and we want to find E and F, then the probability of E or F, so when we see or is the word for union, but when we see or, we're going to be adding events together. So if they are disjoint, they have nothing in common, I will just add the probability of E to the probability of F, and that will give me the probability of E or F. So here I have another sample where you got E, F, and G. All of them are disjoint from each other. Here's a problem which we'll spend most of our time doing examples in my math lab. So here's a deck of cards. You will see some problems that involve knowing deck of cards. So if you're not familiar with playing cards, there's 52 cards in the deck, and they tell you that here. There's 4 different suits. 2 of those suits are black, so half of those 52 cards are black, and then the other 2 suits are red, so that means half of them are red. So you got spades and clubs that are black, hearts and diamonds that are red, and each card has ace, and then 2 through 10, and then jack, queen, king. Jack, queen, king are referred to as face cards. So you do need to be familiar with deck of cards. Each number or card, there's 4 of them, 1 in each suit. So you got some examples, and you can kind of see these with playing cards. So the general addition rule would be if the events are not mutually exclusive, if they do have some events in common, if they overlap. So the probability of E or F generally is the probability of E plus the probability of F minus the intersection. And so let me try to show you a drawing of that, maybe to help you understand what's going on or why they use that formula. Highlight it for some reason, I don't know why. Okay, so let's talk about this formula, generally speaking. So if I have a sample space, and I'll just call this first one A, and I'll call this circle B, and I want to find the probability of A or B. Okay, sometimes they use this U symbol, that means union, A or B, same thing. And here's how we come up with that. So when I do circle A, if you notice, circle A has 2 parts. There's a part that doesn't overlap with B, and then there's a part that does. So when I count circle A, I'm counting this and this piece. So I get the probability of A. Okay. Plus, when I count circle B, okay, again, there's 2 parts, a part that doesn't overlap with A, and then there's a part that does. I will count this piece and this piece when I add the probability of circle B. Now notice the part in the middle has been counted twice. Each of these has been counted once, but the part in the middle has been counted twice. So to correct this, we subtract the probability of A and B. And means both. They have to both be in that at the same time. So when I get rid of that, Then I have each piece counted once, and that's how they come up with this formula. Probability of A or B is A plus B minus the intersection. This also works if they are mutually exclusive, because the intersection would just be 0. So if it was like this, and I had two separate circles, you can still use the same formula. That's why they call it general, except the minus A and B would be 0 because they don't have anything in common. Okay, so that's just a little bit of background on that rule. So here are some examples using the addition rule. Y'all spend some time doing that in my math lab. Okay, so the next one we're going to look at is complement. So here's the definition. S is a sample space of a probability experiment. E will denote an event. The complement of E is denoted with E and this little C. Sometimes you might see a little apostrophe up there. But E complement is all the outcomes in the sample space that are not outcomes of the event E. So basically it's everything except for E. And then here's some rules. So if you take E and then everything else, then you get the whole sample space. So E plus not E is equal to 1, or the complement of E. So here's that rule just expressed. If you want to find E complement, you can just take the whole thing and subtract E, and that will leave you with E complement. And so here's an example. You got a big box. The box is your sample space. E would be the event. E complement would be the space inside the box, but not E itself. And that's what they're kind of showing you here. And then you got some problems and some examples that go over finding complement. Okay, so with that, we're going to go ahead and jump into my math lab and start doing some practice problems.